Scenario. A student is spinning a pencil around. Assume the pencil has a uniform mass distribution. The figure shows the pencil is fixed to a pivot point P that the thumb is on. The pencil is initially rotating without friction in the clockwise direction. At some time t, three forces of equal magnitude, which means equal strength, are applied on the pencil as shown. Question. Is there a non-zero value for the net torque acting on the pencil? Explain. What I mean by non-zero value is that the net torque is like 1 Newton meter, 2 Newton meter, or 3 Newton meter. It has a value besides zero. The answer. The pencil is not in equilibrium. It's still moving. Therefore, there is a net torque. So there is a non-zero value for the net torque because all three forces here don't cancel each other out. The next question. What is the direction of rotation for the pencil after the three forces are applied on the pencil? Well, if the pivot point here can be seen as x is equal to 0, F2 doesn't do anything because the r is equal to 0. We know that the torque is going to depend on the radius perpendicular times the force. Same thing here for torque for F3. Radius F3. Okay. Now we can now compare it. The answer. There's going to be a graded torque for the F1 because the distance away is greater. So R perpendicular 1 is going to be greater than R perpendicular 2. Since the radius is bigger and the forces are the same, the torque for 1 is going to be greater than the torque for 3. Therefore, there is a net torque in the counterclockwise. How do I get it? Because F1 is going to swing the object this way, and that is going to be your counterclock. Next question, what is the angular speed of the pencil? How is this angular speed of the pencil changing, if at all? Well, originally, we said that it was going clockwise. Now, the F3, which is the net, supplying the net torque, is going to be in the counterclockwise. Those two will be in conflict with each other. They're going to, one is positive, the other one's negative. So since the net torque here is counterclockwise and the initial direction is clockwise, the net torque would be slowing down. The angular speed of the pencil is slowing down as a result. Therefore, the angular speed is going to be decreasing as a function of time. Due to the F1 being in the opposite direction, it's going to slow down the clockwise rotation. Okay, and it doesn't matter which one is stronger. But to a point, it's going to slow it down because the F1 is in supplying a net torque in the opposite direction. There you go.